Okay, in this presentation we're going to look at a very straightforward question just to start us up. So we have a complex number here, z or z. I'll just say z because I'm in Ireland. Z equals 7 minus I over 1 plus I, okay? And write z in the form a plus bi, which is straightforward rectangular form. Form the quadratic equation whose roots are z and conjugate of z, z bar, okay? And so that doesn't come out so well. That's z bar there, okay? I just realized that. So z bar. Okay. So what we're going to do here is to simplify this expression. It's essentially a division of a complex number by another complex number. So z equals 7 minus I over 1 plus I. And what we do here is we multiply above and below by the conjugate of the denominator. So the denominator here is 1 plus I, and the conjugate therefore is 1 minus I. And we multiply above and below the numerator and the denominator by multiply them both by the conjugate. Okay, so for the denominator, okay, we have 7 minus I times 1 minus I. Okay, so 7 times 1 minus I gives us 7 minus 7I, and minus I times 1 plus minus I times 1 minus I gives us minus I plus I squared. Plus I squared is equal to minus 1. Okay, so we have 7 minus 1, that gives us 6. Minus 7I and minus I gives us minus 8I when we add them together. So that's the denominator. The numerator, sorry, that's the numerator, and this is the denominator. 1 minus I times 1 plus I times 1 minus I. Work that out and we should get 2 there fairly quickly. Okay. So z is equal to 6 minus 8I over 2, which is equal to 3 minus 4I. Okay. So just one little step beyond that is the complex conjugate of that is 3 plus 4I. So they are the two roots there. So what we're going to do now is build a quadratic equation with those two terms as the roots. So I just started a new page here. So here's our two roots. Based on a different exercise, I am going to call one root alpha and the other root beta. Okay. So the equation is x minus alpha. So this is how we build our equation based on those roots. X minus alpha times x minus alpha times x minus beta. So when we multiply that out, we get x squared minus alpha x minus beta x plus alpha times beta. Okay. Now this just matches up with a different question that I have used in this tutorial sheet. So that works out to be x squared minus alpha plus beta times x plus alpha times beta. Okay, so essentially what we have to do here is just add the two terms, z and conjugate of z, and then multiply them out. Okay, so we add them together, we get 3 minus 4i plus 3 plus 4i. Okay, the minus 4i and plus 4i cancel out, so we're just left with 3 plus 3, that gives us 6. Okay, and now alpha times beta, so we go 3 minus 4i plus times 3 plus 4i, and actually I've worked this out the long way here, but actually equivalently that is actually also the difference of squares. Okay, so that would be 3 squared plus 3 squared minus 4i squared, which gives actually 16 I squared, which would be plus 16. Okay, so anyway, work it out. 3 times 3 plus 4i gives us, well actually I got the signs mixed up there, but essentially all those terms there work out when the minus 12i and the plus 12i cancel out, so we're left with 9 plus 6 equal to 25. So our expression ends up as x squared minus 6x plus 25. There we go, that's a great start.